All right. Hello, everyone. My name is Ruben, and I'm going to talk about ERC-4337 Paymasters today. We've audited most of the heavily used Paymasters out there, so our client list includes Alchemy, Pimlico, Trust Wallet, and many more. I want to give a mini overview over ERC-4337, but it's going to be extremely challenging in the time window. So basically, it's an additional abstraction layer on top of the Ethereum transactions. Users no longer submit Ethereum transactions, but so-called user operation structs. They send these to bundlers, which bundle many of these user operations into a single Ethereum transaction, with the target contract being the entry point. And the entry point is this canonical contract, which basically orchestrates the validation phase and the execution phase of each user operation. In the validation phase, essentially the on-chain interaction gets unlocked, the account wants to do, basically on the account side with a signature validation mainly, and optionally in step 3, if a paymaster is used, the paymaster validation is invoked, followed in step 4 by the actual execution phase, where the on-chain interaction happens. An optional post-op call after the execution phase, and at the very end, the bundler gets compensated either by the account or if a paymaster was used by the paymaster in order compensated for putting the action on chain. There's generally two types of paymasters. So there's ERC-20 token paymasters, which enable user op inclusion in exchange for equivalent ERC-20 token gas payment. And there's verifying paymasters, which are usually used in sponsoring settings, where there's just a signature check being performed on-chain after a series of off-chain checks to determine if a user op is eligible to be sponsored. Think of, for example, like a launch campaign where someone wants to sponsor all the gas costs with some DeFi protocol. ERC-20 token paymasters, which are the ones I'm going to be mainly talking about, have to ask themselves the question when to charge the user. So it will either be as part of the validation phase in step 3 or as part of the post-op call in step 5, where they transfer out the tokens from the user to the paymaster or to some other entity. Naturally, you would first think to do it in the post-op call, because that's actually when you know how much gas was being consumed. But there's some problems here because the post-op call is after the execution phase of the user operation. And the execution phase is inherently non-deterministic. A lot of restrictions are put in place in 4337 on the validation phase to have deterministic outcome of the validation phase, but that does not apply to the execution phase. In case the post-op transfer would fail, the paymaster would still be required to pay because the validation has already passed. So if a user, for example, would revoke the approval as part of the execution phase, the paymaster would not be compensated for their efforts. The paymaster can roll back the execution phase of the user operation, but still has to pay. So this is a very real gas griefing attack. And what's interesting is that the logic essentially or the error happens like within the context of 4337 and not so much in the logic of the smart contract code, but requires the context of the standard. So you can also transfer in the validation phase, which is a better approach because then you have guaranteed payment. However, there's in total 5 user op gas limits based on the arrows I showed earlier. And you have to nail the math between the gas limit, ETH, and then the ERC-20 token conversion. So all the typical Oracle and decimal issues apply we see in all audits. And also, on a side note, I don't have time to go into this much, but please do not revert due to stale Oracle data, but encode it as part of the return validity window. If you have any questions on that, send me a DM. I don't have time to talk about this more. Basically, what you end up doing is you end up overcharging the user in the validation phase based on the gas limit specified. So basically, you specify the maximum amount of gas a user operation can use, and the actual usage might have been significantly lower than that. So you can return the excess change in the post-op call. However, you should be aware that there's a gas penalty of 10% of all the unused gas. That's basically the difference between the actual gas the user operation consumed and the limits that the user specified. And if the paymaster does not account for that limit correctly, then it either ends up undercharging the user or overcharging the user. Either way, there's a financial loss happening there. There's many more I would have liked to talk about, but I'm extremely constrained on time. So here's a list. You can find most of these issues on our public audit website, certificate.quantstamp.com. And also feel free to DM me on X or Telegram for more. Thank you so much.
I think so. I have it.